Have you ever wondered what Earth looked like before the age of dinosaurs? Let us journey back to the very inception of our planet, about 4.5 billion years ago. Picture the early Earth, not as the blue and green orb we know today, but as a seething, molten mass gleaming red-hot under the primordial sun. This was a world in the throes of formation, violently bombarded by comets and asteroids, each impact contributing to its mass and heat. Amidst this cosmic onslaught, Earth began a gradual process of cooling. Over millions of years, the surface temperature decreased, allowing the first solid crust to form. This newly forged crust was the canvas on which the entire history of our planet would eventually be painted. It was rugged, unstable, and constantly reshaped by the forces churning beneath it. From a fiery ball of molten rock to a stable crust, Earth's journey was just beginning. Imagine a world without water, hard to picture, isn't it? Yet there was a time, billions of years ago, when our blue planet was devoid of oceans, rivers, and lakes. The story of how water came to be here is as fascinating as any tale from the cosmos. The prevailing theory suggests that water arrived on Earth through icy comets. These celestial wanderers, roaming the early solar system, bombarded our young planet. As they crashed into the Earth, these comets, composed mainly of ice and rock, melted upon impact due to the intense heat, releasing vast quantities of water. Over millennia, these contributions accumulated, gradually forming the oceans we know today. Simultaneously, the Earth was undergoing another transformation. Volcanoes played a pivotal role in shaping our planet's early atmosphere. In their fiery wrath, these geological giants spewed out gases like carbon dioxide, water vapor, and ammonia. This outgassing, a process as dramatic as it sounds, created a primordial atmosphere vastly different from the one we breathe now. This early atmosphere and the presence of liquid water were crucial. They created a more stable environment where temperatures could moderate, weather systems could form, and importantly, the conditions necessary for life could develop. This was no overnight metamorphosis, but a gradual process that laid the groundwork for all future biological phenomena. With water and a new atmosphere, Earth was setting the stage for life. Now, let's dive into when life decided to make an entrance. Imagine a world billions of years ago, stark and barren, yet on the brink of something extraordinary. Around 3.8 billion years ago, the first whispers of life began to stir in Earth's primordial oceans. These were not the complex creatures that we are familiar with today, but rather simple, single-celled organisms, most akin to modern bacteria. These microscopic pioneers were the architects of life as we know it, setting the stage for every creature that followed. Among them, a particular group called cyanobacteria began to harness the power of the sun. This process, known as photosynthesis, was revolutionary. By converting sunlight into energy, these tiny organisms began to produce oxygen as a byproduct. Now let's pause and consider the monumental impact of this development. Before the advent of photosynthesis, Earth's atmosphere had very little free oxygen. It was primarily composed of nitrogen, carbon dioxide, and inert gases. The oxygen produced by cyanobacteria began to accumulate, slowly but inexorably changing the composition of the atmosphere. This leads us to one of the most critical events in Earth's history, the Great Oxygenation Event. As cyanobacteria flourished and spread, they pumped out oxygen, which built up in the atmosphere and dramatically altered the planet's chemistry. This event wasn't just a slight adjustment, it was a radical transformation that led to the mass extinction of many anaerobic life forms that thrived in the absence of oxygen. However, this shift also cleared the path for aerobic organisms, those that require oxygen, which included more complex and diverse forms of life. The increase in atmospheric oxygen is believed to have eventually led to the formation of the ozone layer, which further shaped Earth's environment by shielding the surface from harmful solar radiation, thus making it more hospitable for new forms of life. Oxygen was a game-changer, reshaping Earth's atmosphere and paving the way for more complex life. Volcanoes played more than just a destructive role on early Earth. Imagine a world where the surface is alive, not just with creatures, but with the very land itself. In Earth's formative years, intense volcanic activity wasn't just common, it was a pivotal architect in the planet's development. During this turbulent period, known as the Hadean and Archean eons, the Earth was practically a canvas of molten rock. Volcanoes erupted with a frequency and intensity unlike anything seen in the modern age. These fiery giants did more than spew lava, they were the forges of the Earth's early atmosphere. As they erupted, they released vast quantities of gases, including water vapor, carbon dioxide, and nitrogen. These emissions began to accumulate layer by layer, crafting an atmosphere that would eventually support life. But the contributions of these volcanic behemoths didn't stop at the air we breathe. The minerals and elements belched forth in their eruptions dissolved into the primordial seas, enriching them with the nutrients necessary for the first microbial life forms to thrive. These nutrients played a crucial role in the evolutionary drama that would unfold in the oceans. The land itself owes its existence to these volcanic processes. As lava flows cooled and solidified, they helped form the Earth's crust. Over eons, tectonic forces shuffled these volcanic deposits, leading to the formation of massive landmasses and supercontinents like Rodinia. This ceaseless activity laid down the foundations of the modern Earth. Through fire and ash, volcanoes sculpted the surface, creating and rearranging continents. Volcanic activity was crucial in crafting the continents we recognize today. Continents on the move, let's explore this continental ballet. Imagine the Earth, not as a static ball of rock hanging in space, but as a dynamic, ever-changing canvas. This idea is at the heart of the theory of plate tectonics and continental drift, a concept that revolutionized our understanding of the planet's past and continues to shape our world. The theory of plate tectonics tells us that the Earth's outer shell, or lithosphere, is broken into several large plates that float on the semi-fluid layer beneath, known as the asthenosphere. These tectonic plates move, driven by currents generated by the heat from the planet's interior. The interactions of these plates can lead to earthquakes, volcanic activity, and most dramatically, the movement of continents. Now, let's rewind the clock to over 2 billion years ago, to witness the first known supercontinent called Columbia. Then came Rodinia, which formed about 1 billion years ago and later fragmented. These massive landmasses didn't just sit there, they broke apart, their pieces drifting and reassembling in a slow, majestic dance, giving rise to new supercontinents. One of the most famous of these was Pangaea, which existed during the late Paleozoic and early Mesozoic eras. Formed about 300 million years ago, it began to break apart around 200 million years ago. This breakup fundamentally altered the world's geography, influencing ocean currents, climate, and biodiversity. The drifting continents created not only physical barriers but also new and diverse habitats. Mountain ranges thrust up by the colliding plates altered weather patterns. Shallow seas formed in the rifts of the splitting continents, becoming cradles of new life forms. These changing conditions set the stage for dramatic shifts in life on Earth, including the rise of new ecosystems. Indeed, this dance of the continents was not just a spectacle of geological movement, it was a profound transformation that affected everything from the climate to the sea levels, creating environments that would eventually be home to a vast array of creatures, including, in time, the majestic dinosaurs. The shifting continents were setting the stage for a world that dinosaurs would one day roam. Before the mighty dinosaurs, what creatures ruled the Earth? Long before the thunderous roars of dinosaurs echoed through the Earth's valleys, the planet was a stage for an entirely different cast of characters. Among these were the trilobites, with their hard calcified exoskeletons navigating the ancient seas. These fascinating creatures dominated the oceanic landscapes, showcasing an incredible variety of forms and sizes, and were among the planet's earliest arthropods. On land, the narrative was equally intriguing. Early amphibians began to make their tentative steps onto the soggy shores, evolving from fish that had developed the ability to breathe air and venture out of the water. These pioneers, like Ichthyostega, were crucial in the transition of life from water to land, setting foundational biological blueprints for those who would eventually dominate the Earth. As we delve deeper into the pre-dinosaur era, we encounter the Permian period, a chapter marked by dramatic environmental shifts and volcanic eruptions. This period, spanning from about 299 to 252 million years ago, was a time of significant biological experimentation and diversity. However, it culminated in the largest mass extinction event in Earth's history, known as the Permian-Triassic extinction event. This catastrophic event wiped out approximately 96% of marine species and 70% of terrestrial vertebrate species, effectively resetting the evolutionary clock. This mass extinction paved the way for new forms of life to emerge and dominate, a testament to the resilience and adaptability of life itself. The ecosystems gradually recovered and new life forms evolved, filling the niches left vacant by the Permian catastrophe. The stage was being set for a new era of giants. The stage was now set, and soon, the Age of Dinosaurs would begin. As we reflect on these prehistoric periods and events, it becomes clear that understanding them is crucial for appreciating the full tapestry of life's evolution on our planet. They remind us that life, through all its trials and tribulations, finds a way to endure and evolve.